Here we have a story problem. In a class of 28 students, 11 say that chocolate is their favorite flavor of ice cream. What percent to the nearest tenth of a percent of all students in the class have a favorite ice cream flavor that is not chocolate? This is very similar to the last example we did in the notes, because we have a lot of different approaches we could take because it's giving us the number that do like chocolate and it's asking for the percent that do not like chocolate. So we could either do our subtraction at the beginning or at the end, and we could do translation method or proportion method here. So if I do my subtraction at the beginning, I could go ahead and say 28 minus 11. That is going to give me 17. And so that means that 17 out of 28 students, so 11 did say chocolate was their favorite, so 17 of those students do not prefer chocolate as their favorite. And so then we could do translation or proportion methods from here. So if I were going to do this with the translation method, I would probably translate this or summarize what it's asking me to find, right? So it's asking me what percent, and it wants the percent of all students in the class that do not have chocolate as their favorite. And we already know that that's 17. So we could say what percent of the 28 students is the 17 that don't prefer chocolate. So that would be one way to ask this question. And then once we kind of summarize that, then we could translate that to an equation. So what percent, I would use my variable. I'm just going to use P for percent, but you could use X or A or anything you want. Of means multiply, so I would multiply that by 28. Is would be my equal sign, and so then that would be is 17. So this might be how I might choose to set this up. Now, when you're looking at student work, that means you're going to have to look at the student work and see if it looks like that. So are there any of them that look like that right now? Well, actually there are, right? So this first one looks like that. They've used X instead of P, but it's the same other than that, right? Looks like we've got some proportion methods, so I'm going to have to try that method as well. But it's good just to kind of look and see if I see any others that look like that. If I look at this, I can see 0.28p equals 28 minus 11. That one's interesting. So that one right there, 28 minus 11 is how we get 17. So this is really the same thing as saying 0.28p equals 17. And that looks really similar to what I've written down. The only difference is they have 0.28. But remember that if I were to solve this, right, I would have to divide both sides by 28, and that would give me a decimal. And then I would have to change that decimal to a percent by moving the decimal 2 spaces. So essentially what they've done here, it's a little different, but essentially they've already moved the decimal 2 spaces by making that 0.28 instead of 28. So it's a little bit tricky, but yeah, that's real life. That really is how this works, is like you see students do all kinds of methods that doesn't necessarily look exactly like what you have, but if you really take the minute to analyze it, it's like, oh, that actually is, it's the same thing as what we've done, right? It's just shown a little bit differently. They didn't go ahead and subtract 28 minus 11 yet, and they went ahead and wrote it as 0.28 to kind of go ahead and deal with the fact that they have to change that decimal to a percent in the end. So I at least found a couple that work here. So I want to go ahead and try this with some other methods to see, especially since it looks like a lot of these are using proportion methods. So I might try that and see if I come up with something similar to what these students have. So where we're trying to find what percent of 28 is 17, we can say I don't know the percent, so you could use X or P or whatever you want to use, and then put that over 100. And then I know the is part is 17, and the of part is 28. So I would do is over of. So this might be how I would set up this problem using a proportion. So let's see if I see any that look like that. And so, yes, I am right below this actually. 17 over 28 equals x over 100. The only thing they've done is they've used x instead of p, which is perfectly fine. So that one works. That's a correct proportion here. It looks like some of the other proportions that I'm seeing, like this one and this one, they're using 11 instead of 17. So it looks like they may just didn't do their subtraction yet, right? Which is okay. We did our subtraction at the beginning. Maybe they're just doing their subtraction at the end, right? So I'm not seeing anything really bad about these. I'll check them by using another method, but they don't match exactly what I have. So let's try the other method then. Instead of subtracting right away by doing the 28 minus 11 to get that 17 students do not prefer chocolate as their favorite, let's just go ahead and do this without subtracting first. So doing it this way, we would really be saying what percent of 28 is 11, right? So 11 students had a favorite flavor being chocolate. And so doing it this way, it would find the percent that actually prefer chocolate, and then just at the end I would have to subtract that from 100% to find the percent that do not prefer chocolate, right? So it's the same idea, I just subtract at the end instead of the beginning. So if I did this with the translation method, I could do P for what percent of means multiply by 28 and then equals 11 would be is 11. And so do I see any that look like that? I am seeing some. So this one looks the same as that, right? So they've used N instead of P, but it doesn't matter what variable you use. And they've done 28 times N instead of, P times 28. They changed the order, but it's the same thing, right? So that one works pretty well there. What else do we have here? Trying to see if any of these look similar. Looking at this one, let's see, 28x equals 1100. So if we look at that one, that's a little bit different. So on ours, if we did it, we would do 11 divided by 28. They would do 1100 divided by 28, right? But remember that when we're done with this, like when we divide both sides by 28, we're going to get a decimal, and then we have to change that to a percent, right? So we have to move the decimal 2 spaces, which is the same thing as like dividing it by 100. So that's really what they've done here, is they have already factored that in, already factored in the fact that they're going to have to change it to a percent. So it's a little different, but it is actually the same. It works the same way here. It is a good setup. So this is really a good method that we're going through. It's just kind of coming up with our own methods for how we could solve this, and then seeing if the student work looks the same or similar and figuring out from there if it's correct. So I'm going to try one more method, which is to do this, what percent of 28 is 11, but to do that with a proportion. So I would do that as what percent would be P over 100, and then that would be equal to the is part would be 11 and the of part would be 28. So it's the same thing as what we did over here, right, with this proportion, except we didn't subtract the 11 from 28 yet, right? We would do that later. When we find an answer, we would then subtract. So do I see any that look like that? I'm looking at this one and I'm saying, actually, that one doesn't look like that. So it is similar, but the problem is that they've swapped these two, right? If they had swapped these as well, that would be okay. It'd be a little different, but it would be okay as long as they kept it consistent. But they've used A instead of P. So they've got the A over 100 part, but then instead of 11 over 28, they did 28 over 11. So that actually shows me kind of what they were thinking, but it also shows me that that one does not work. This one is the exact same as what I have here, right? So they've used a percent sign instead of a variable, but that's just fine, right? So they're using that percent sign to represent what's missing. Other than that, it looks the same. If I look at this one, let's take a look. So this has P over 28 and 11 over 100. It's got all the same numbers, but yeah, they're not really in the right spots, right? So, you would need to keep it consistent. So like the P should not be over what's diagonal to it. The P could be over 11 or it could be over 100 and that would be okay. But if you've cross multiplied this, you would not get the same answer as if you cross multiplied on the one we came up with. So that tells me that this one kind of shows me they were trying to use a proportion, but that they did not do that correctly. If I look at what's left, because I've only got a couple left here. If I look at this one, it looks kind of like maybe what they were doing here is cross multiplying, like they went ahead and multiplied. But if I went ahead and multiplied, I would have P times 28 equals, and then 11 times 100, right? That's not what I'm getting here. So instead of them getting their variable times 28 and 11 times 100, they're getting 11 times 28 and their variable times 100. So that may be what they're doing. Maybe they set up their proportion incorrectly, almost as if they did it this way, right? If you were to cross multiply that, right? Or I'm sorry, not that way. That way was correct. This one is the one I was thinking of. So if you were to cross multiply that, would that give you the same thing? I feel like there was one that did that. Maybe not. I was thinking it was that one, maybe not. But you can kind of see like it's almost as if they set up their proportion as 11 over 100 equals 28 over x, and then cross multiply that. Is that what they're doing? No, sorry. It's like they did 11 over 100 equals x over 28 is what it looks like they did. Because if you did that, if you cross multiplied 11 times 28 and 100 times x, right? Took me a while to get there, but that's kind of what the proportion they might have started with to get here. And if you look at that proportion, it does not look like what we have. It would not give you the same thing. So that tells me that that one does not work. So then I've got one more to check, which is this one. And that one's a little bit different. So it's like, are they using a proportion method or are they using a translation method or something else here? And this actually works. So this is a little different method. But basically it's taking the is part over the of part. If you do that, that will give you a decimal. And so then if you want to change that decimal to a percent, you would simply multiply it by 100. So that's essentially what they're doing here. And you can kind of see how that works. So if we look at the proportion that we wrote right here, why does that work? If I were to cross multiply this, right, I would get P times 28 equals 11 times 100, right? And then what I would do is I would divide both sides by 28, right? Usually I would go ahead and multiply 11 times 100 and get 1100, and then divide by 28 to get the answer here, right? So what I would end up with here is I would end up with 11 times 100, and then take that and divide it by 28. But you would actually get the same thing if you did the division first, 11 divided by 28, and then multiplied by 100. So that's essentially what they did, is they did the same thing, it's just they did the division first instead of the multiplication, and that's perfectly fine. You get the same answer as long as it's all multiplication and division. So that one does work.